Once again, welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And in this video, I'll be explaining example 1 and possibly example 2 on page 67 of IGCSE 9-1. And they are calling it circle theorem 2, whereby we just need to combine all the basic information about circles and be able to calculate a circle and be able to get the angles in a circle. And in example 1, we are told that the diagram first of all looks like this. Let me have it here. The diagram looks like this. There is a line a chord that is produced. There is another chord that is produced here, and there is this diameter. First of all, there is this diameter of the circle with center O. That is center O. And there is this chord that joins there. And of course, there is a small chord here that completes the diagram, and this is L, N, we have Q, M, and P. We have O there. Let us now, we have 25 degrees. We have 25 degrees there. And the question is, find angle P and M. Angle P and M. That small angle is what we're supposed to find. And again, okay, we have been given another angle which is 35 degrees there. And I think that's where we need to start. Basically, when we have this angle as 35 and it is subtended by this chord to the circumference, you realize that the same chord subtends this angle to the same circumference in the same segment, bearing in mind that what you've just learned to if you consult the basic information and have it here, you will see that we are dealing with this kind of a situation. The chord AB subtending X, subtending X, subtending X in the same segment regardless of the position. So this means, therefore, even this angle by itself, since it is subtended by this chord in the same segment, this is also 35 degrees. It goes without saying. Having said that, you will see that LM is a diameter, and it goes without saying that this LM being diameter subtends an angle of 90 on the circumference. So let me just say M, the angle NPM. The angle NPM is 35 degrees. And the reason being, angle subtended by the same chord in the same segment. They are equal. Having said that, let me also say that angle L and M, angle L and M, angle L and M is 90 degrees. Reason being, it is subtended. It is subtended on the circumference by the diameter. Any angle subtended by the diameter on the circumference is 90 degrees. And that means also the angle M and Q, the angle M and Q, M and Q is also 90 degrees because if the angle L and M is 90, then it follows that M and Q is also 90 degrees due to the fact that angles on a straight line, because angles on a straight line add up to 180 degrees, because the angle L and M and Q, they make a straight line L and Q. Having said that, if this is 90 degrees, and I want us to talk about that, if that is 90 degrees, considering triangle P and Q, and let's say considering triangle P and Q, this triangle P and Q, that triangle, and the angle sum of triangle, and the angle sum of a triangle, which is 180 degrees. Considering that triangle and the angle sum of a triangle, which is 180 degrees, then we can talk of that triangle. This angle is 35, this angle is 25. So the whole of that angle is angle P and Q is 180 minus 35 plus 25, because these ones are already there, which is 180 minus 60, which is 120 degrees. The whole of that angle P and Q, the whole of that angle happens to be 120 degrees. But within 120, there is a 90, which is M and Q. Since angle M and Q is equals to 90 degrees, we have had it here, and it is within 120 degrees. It's within 120 degrees. In other words, it is within angle P and Q. Then we just need to subtract 120 minus 90, and we'll be left with the angle. Then angle P and M is equals to 120 minus angle P and Q, which is 120 minus 90 degrees, and this one is easily giving us 30 degrees. So the size of angle P and M is given by the whole angle, or rather 120 degrees minus P and M, this is M, minus M and Q, this is minus M and Q, which is 90 degrees, not P and Q. So P and M minus M and Q, what are we saying? Angle P and M is equals to angle P and Q, which is 120 degrees, minus M and Q, which is 90 degrees. And that's how we found our angle to be 30 degrees. And with that, just be keen, you may get confused here. And I repeat again, angle P and M, this one, is equals to angle P and Q, which is 120 degrees, minus angle M and Q, which is 90 degrees. So P and M is equals to 120 minus M and Q, which means 120 minus 90. And of course, we get 30 degrees. Okay.